Now that we have looked at adding rational expressions, now we're going to look at subtracting. To subtract rational expressions, they must be written with a common denominator. The least common multiple of the denominators is the least common denominator. To subtract rational expressions, when the denominators are the same, subtract the numerators. When one denominator is the opposite of the other, we multiply one expression by -1 over -1 to obtain a common denominator. Now let's look at a couple subtraction problems. These two problems happen to have common denominators, so these are going to be somewhat easy to do. Remember, if they have common denominators, then you keep the denominator and subtract the numerator. So 10 minus 4 would be 6. So 6 over x would be my final answer. This one, my denominator is n minus 10. When I subtract my numerators, I have n minus 10. And since n minus 10 would cancel with n minus 10, we are left with an answer of 1. Now what happens if they don't have common denominators? So this one, our denominators are 8 and 2. So what's the least common denominator between 8 and 2? Well, that would be 8. So we're going to leave the first fraction alone, but the second one we have to multiply by 4 over 4. That's going to give us common denominators. So now my new problem, my first fraction stays the same, and my second fraction becomes 4t plus 8. And remember, that is a quantity, and the way I got that was I had to distribute my 4 to everything in the parentheses. So now I'm going to have, or I have to combine like terms. So my denominator is 8. I have t minus 4t, which would be negative 3t. And I have a negative 3 minus 8, which would be a negative 11. If I could factor my numerator, then I would to see if anything would cancel, but nothing will factor, so that this would be my final answer. Negative 3t minus 11 all over 8. Now let's look at the second one. Again, I would have to get common denominators. So if we look at our denominators, I have 5r squared t, and I have rt squared. So my common denominator has to have the 5, it has to have r squared, and it's going to have a t squared. So I'm going to have to multiply my first fraction. See, it's already got the 5, so I don't have to do the 5. It has the r squared, but it's going to need t over t. And my second fraction needs the 5 for sure. It's only got an r, so it's going to, and we need r squared, so we're going to need another r. And it already has the t squared. So now let's do some simplifying. So for my first fraction, if I distribute my t throughout, I'm going to get 3rt plus t squared all over 5r squared t squared. And now if I distribute my 5r into my second fraction, I'm going to have 25r squared minus 20rt all over 5r squared t squared. And again, remember that we are subtracting that entire quantity. So now I should be able to combine them into one fraction with the denominator of 5r squared t squared. So 3RT minus 20RT is going to end up being 23RT. I have a t squared, so I'll just put that in the front. And then I have a minus 25R squared. Now let's look at a problem that has polynomials in the denominator that need to be factored. Remember, when you see trinomials or binomials that do not have a greatest common factor, think about factoring them a different way. So we need to factor before we can move on. X squared plus x minus 20 is the same thing. X's. Factors of 20 that add up to 1, well, it has to be 5 and 4, positive 5, negative 4. Remember, x squared minus 25 is a difference of squares. That's x plus 5, x minus 5. So when you look at this problem, our least common denominator has to be, well, they both have the x plus 5. And then we need to throw in an x minus 4 and an x minus 5. So, what are we going to multiply each fraction by? The first fraction needs, it's got the x plus 5, it's got the x minus 4, it needs the x minus 5. And what does your second fraction need? It's got the x plus 5, x minus 5. It needs the x minus 4. So let's see if we can simplify this mess. The first fraction, I have to take x minus 5 times 4. So that's going to be 4x minus 20. And the second fraction, I'm going to have to take 3 times x minus 4, which is going to be 3x minus 12. All over my denominator of x plus 5, x minus 5, x minus 4. So I kind of skipped a step there. Instead of rewriting each fraction individually with my new denominators, with my 3 factors, I just kind of skipped that step and just wrote it all as one. Now let's simplify the numerator. I have 4x minus 3x, so it's going to be x. I have a minus 20 minus minus 12, so that's really minus 20 plus 12, which is a minus 8. All over my denominator of x plus 5, x minus 5, x minus 4. And that's my final answer. Now let's look at this next one. We have 2a minus 5 over 15a minus 7a minus 1 over 10a. The least common denominator in this problem is going to be a little bit easier to identify. They both have a's, and so we just need to work with the numbers 15 and 10. 15 and 10 both go into 30, so I'm going to multiply my first fraction by 2 over 2, and I'm going to multiply my second fraction by 3 over 3. So now let's simplify. I'm going to have 2 times 2a minus 5 is going to be 4a minus 10 minus, take my 3 times 7a, so 21a minus 3, all over my denominator of 30a. Now let's simplify. 4a minus 21a is going to be a negative 17a, and a minus 10 minus minus 3 is really a minus 10 plus 3, so it's going to be minus 7 all over 30a. Now this last one. You might notice that the denominators are opposites of one another. So when this happens, just multiply one of them, and it doesn't matter which one, but I'm going to multiply the second one by negative 1 over negative 1. What that does is it's going to give me 3 over x minus, and then I have 9 times negative 9, or sorry, 9 times negative 1, so it would be negative 9, over negative x times negative 1, which is positive x. That's going to give me 3 minus minus 9, or 3 plus 9, which is 12 over x. So if you notice that your denominators are just opposites of one another, all you have to do is multiply by negative 1 over negative 1, and then your denominators will be the same.